Okay, good morning. Today we'll discuss about pulse code modulation and demodulation. So this is the second experiment, part B, second experiment. So here first you need to open the MATLAB. After that you need to open the Simulink, and we need to construct this diagrams using here library browser. So just click on the library browsers and what are the components you need, select it and drag it here and connect as per this diagram. Just I give a brief idea about this block diagram and output. So the components are required for this implementations of pulse code modulations and demodulations are, the first one is sine wave, okay, sample and hold circuit, encoder, integer to bit converter, bit to integer converters, and uniform decoder and filters. Along with that, two scopes, and along with that we need a pulse generators. So why scope are required? Scope are required to check the output. Now before that you need to assign some specific value for that. Just click on that sine wave. So what are the values you need to mention here? Amplitude is 5 and frequency is 2 pi 2, and all of you note down these values. This is very important because you won't get an output for any values. Okay, so you need to assign some particular values to get a desired output. So here amplitude is 5 and frequency is 2 pi 2 uh, and sample time is 0. Okay, fine. Just apply and OK. Yeah, I already assigned value. Just I am showing to you. Next, click on the sample and hold. Sample and hold. See, a trigger type is rising heads and initial condition is 0. Just click on that OK. Then click on that uniform encoder. Okay, uniform encoder, its peak value is 5 and bits is 3 and output is signed integers. Okay, just click on the OK. After that integer to bit converter, just click on that integer to bit converters. So number of bits integers are 3 and treat input value as signed, output bit is MSB first and output data type as internal rule. Just click on that OK. Same thing, a bit to integer converter. Similarly here number of bits are 3 and input bit are the MSB first and after bits treat resulting integer value as signed and output data type is internal via internal rule. Just click on that OK. Then similarly uniform decoder, peak value is 5, bit is 3 and overflow is saturate and output is data type double. Okay, then filters, analog filter design. Just note down that component values also, because in the library you need to give a proper component name. Okay, then only you will get that. Then here design method is Butterworth low pass filters. So filter order is 8 and frequency band is 2 pi 2. Just click on that OK. Next is pulse generators. Pulse generator is amplitude is 5 and period is 1 by 20. So pulse width is 50. Okay, pulse width is 50 and phase delay is 0. Okay, so these are the specific values you need to assign for implementation part. Just I'll give a brief idea about that how the circuit is work. So pulse code modulations, it is a digital modulation technique. Now just I am considering a one input here analog sine wave. First you need to convert the analog into a digital. So how will convert using an sample and hold, okay, sampling and quantization. Okay, so here this first sample and hold which converts the analog into a discrete values. So after that this is with respect to quantizations. Okay, quantizations, or you can say that an encoder, it performs an encoding operations here. And next it convert integer to bit converters. So here there are two scope, and this is the scope 1 and this is the scope 2. In the scope 1 you can observe the outputs of here integer to bit converters. It consisting of mainly two parts here. This block diagram is consisting of two parts, transmitters as well as in a receiver, modulations as well as in a demodulations. So from beginning to at this point, okay, at beginning to this point it is called as a transmitters and this is called a receiver part here. Now So if you want to a modulated output, where you will get the modulated output? At scope 1, because here this it is connected to a scope 1. So hence you will get here in the scope 1 we can observe the modulated output, okay, output of the sample and hold and a pulse generator along with that input. Just I want to click here, click the scope 1, so will the observe, okay, we'll check the output. So before that just save it, save it and run once again. How to run? Just click on this run button. Yeah, okay, now just click on the scope 1 and check the output here. See here, so here this is the first input, because here, yeah, one input is directly given to scope, okay, directly given to scope. Actually the scope has the total of 4 outputs here. One is directly applied to input, then a sample and hold circuit and pulse generators and output of the integer to a bit converter. Now look at here. So these are the 4 outputs. The first one is an just input, and this second one is an a sampling, okay, samples, okay, these are the samples. Third one is an encoder, quantizations, and fourth one is the, okay, this is the PCM output, okay, modulated output. The last one is the PCM modulated output, okay. So this is an modulations. Now come to the point with respect to demodulations. With respect to demodulations, where we need to observe the output, you need to observe at scope 2, okay. See here, listen very carefully. Here scope 2 has 2 input, one from directly applied to from input and another from demodulated output. Why I am connecting here input directly? Just for comparison purpose. I am going to compare the input and the demodulated output, okay, that's why I connected like this. Now just click on that here. Yeah, see here. These are the input and demodulated output. So actually this is an input. So what we have applied for the sine wave input is a 5 volt, correct? And this is the above one is the demodulated output. So in the demodulated output there is a little bit distortions. Okay, so you will get a less amplitude due to noise in the component. Okay, so these are all about PCM modulations and demodulations output. You need to check both modulation output and demodulations output, and here demodulations output at the scope 2 and a modulation output at the scope 1. Okay, just once again show you. This is the scope 1 output. Okay, so the last one is pulse code modulations output. Okay, modulated wave. Okay, so this is all with respect to a pulse code modulations and demodulations circuit implementation of the same. Okay, yeah, thank you.